Are you ready to revolutionize your factory operation by 2025? With the rapid advancement in technology, the manufacturing sector is undergoing a transformation like never before. From automation and AI to vision systems and advanced robotics, those emerging trends are set to redefine how we think about production. In today's video, we are diving deep into what we can expect in smart factories by 2025.
Welcome to my channel, Simple-WhenExplained, dedicated to simplifying complex technology with over 20 years of engineering expertise. I'll guide you through practical advice and real-world examples. Complex concepts become clear. Join me on this exciting journey to explore technology together. Subscribe now, and let's ignite your passion for technology.
First off, let's define what a smart factory is. A smart factory leverages technologies such as automation, artificial intelligence, AI, and advanced robotics to optimize manufacturing processes. The goal? To create an environment where machines communicate with each other and make decisions autonomously, minimizing human intervention while maximizing efficiency and productivity. Here is what we will be covering: advanced automation, artificial intelligence, vision systems, and advanced robotics. So buckle up, it's going to be an enlightening ride. Let's start with automated production lines. Those are no longer just a futuristic concept, but a reality in many modern factories. Automated production lines significantly increase efficiency by reducing human error and speeding up production times. Take, for example, automotive giants like Tesla. They have fully automated assembly lines that work around the clock without fatigue or error common among human workers. This shift had led to substantial cost saving and productivity boost for them. Imagine implementing this level of automation in your factory. Fewer errors mean less waste and higher quality product rolling off your production line at a breakneck speeds. Next up are autonomous mobile robot, AMRs. Unlike traditional robots confined to a specific task or locations, AMR can navigate through dynamic environments independently using advanced sensors and software algorithms. One exciting example is Amazon's use of AMRs for material handling within their warehouses. Those robots efficiently move items from storage shelves directly to packing stations, drastically reducing manual labor cost and increasing throughput rates. However, I know some of you might be concerned about job displacement due to those robots. It's crucial to look at it from another angle. Those technologies also open up opportunities for retaining workers into a higher skilled roles that oversees robot operations or managing data analytics. Now let's delve into AI-driven predictive maintenance. A game changer when it comes to reducing downtime in manufacturing plants. Predictive maintenance uses AI algorithms along with IoT device sensor data analysis capabilities to predict equipment failures before they occur. For instance, General Electric uses AI-driven predictive maintenance across its various industrial divisions, from jet engines down to power turbines. They have reported significant cost saving by avoiding unexpected breakdown while ensuring optimal performance level throughout their machinery fleets' lifespans. Sensors embedded within equipment continuously monitor vital parameters such as temperature fluctuations or vibration patterns, triggering alerts whenever anomalies arise and indicate potential failure points. This proactive approach ensures minimal disruption during operation while maximizing asset utilization rates. Quality control is another area where AI shines brightly. Traditional quality checks often rely on periodic inspection, which may miss subtle defects, leading to compromised product quality standard over time. However, With real-time data analysis capabilities offered by AI-powered systems, you will catch even the minute deviation instantly, ensuring consistent output and excellence every single batch produced. For example, the semiconductor industry relies heavily upon precision engineering, demanding utmost accuracy level during chip fabrication processes. Companies like Intel utilize sophisticated machine learning models capable of identifying microscopic imperfections invisible to the naked eyes, thereby guaranteeing top-notch end-user experiences. By incorporating advanced vision systems coupled with intelligent algorithms, we are witnessing unprecedented improvement not only in product quality, but also in customer satisfaction metrics, soaring to new heights altogether. Machine vision technologies play a pivotal role enabling seamless inspection processes across diverse industry, ranging from automotive to pharmaceutical alike. By leveraging high-resolution cameras combined with state-of-the-art image processing techniques, we achieve unparalleled accuracy, detecting defects in early stage, preventing costly rework downstream pipeline altogether. Continuous improvement in computational power enable faster processing speeds, delivering results in real-time scenario critical in maintaining smooth operational workflow, seamlessly integrating existing infrastructure effortlessly. Applications span a wide spectrum from inspecting solder joint in electronics component and verifying label accuracy in pharmaceutical packaging unit, all ensuring the highest possible standard maintained throughout supply chain globally. The synergy between vision system and robotics is truly remarkable indeed. When integrated together, they perform precise tasks in assembly and sorting operation flawlessly, achieving unmatched efficiency levels previously thought unattainable by conventional methods alone. Consider a scenario where a robotic arm equipped with advanced camera module is tasked with assembling an electronic circuit board, requiring utmost precision while executing complex maneuver consistently and accurately every single time. Looking ahead, the future possibilities are vast, especially with the development of fully autonomous inspection units. Those units will be able to perform a wide range of activities independently, without any human intervention. This advancement will pave the way for next-generation manufacturing paradigms, completely redefining the industry. In summary, the future of manufacturing is poised for groundbreaking changes, and autonomous inspection units are in the forefront of this transformation. This message is intended to be conveyed clearly, effectively, and efficiently. Collaboration robots, or Cobots, are designed to work safely alongside humans, fostering collaboration environments in workplaces around the world. They bring about an era of coexistence where symbiotic relationships are consistently and sustainability enhanced. Those robots are reliable, undeniably effective, and have been proven to boost productivity and organizational achievements. Their dynamic and vigorous nature reflects a strong commitment to excellence, aiming for specific goals and objectives. Cobots represent an enhanced modern workspace standard through innovation and reliable solution. Their successful integration into workspaces signifies a monumental shift toward a smarter, more agile operations. With strong emphasis on safety, those robots are designed to detect and respond to human presence, ensuring harmonized and productive work environments. Versatile across industries, from manufacturing to healthcare, robots continually expand their applications, enhancing effectiveness and strategic outcomes. As technology advances, cobots will become even more crucial to organizational success, revolutionizing standard procedures and driving innovation in modern workplaces. To wrap up, let's recap the transformative trends we have discussed. Advanced automation with automated production lines and autonomous mobile robots, manufacturing processes are become significantly more efficient. Artificial intelligence, predictive maintenance, and AI-driven quality control systems are ensuring operational efficiency and high product standards. Vision machines, vision technology, and its integration with robotics are enabling unparalleled accuracy and real-time inspections. Advanced robotics, collaborative robots, Cobots, are fostering safe, productive environment and revolutionizing the way humans and machines work together. As we project into the future, we can anticipate even more groundbreaking development by 2025. Smart factories will likely see an uptick in fully autonomous operations, enhanced by more sophisticated AI algorithms and even more capable robotics. This will provide unprecedented level of efficiency, flexibility, and productivity across the manufacturing sector. If you found today's exploration of the future of Smart Factory insightful, don't forget to subscribe to our channel. We invite you to leave your thought, your question, or experience related to those emerging trends in the comments below. Let's continue the conversation and stay ahead of the curve together.